Bismillahirrahmanirrahim. Assalamu alaikum. Today we are going to start the 6th lecture of discrete mathematics. In the previous lecture we have studied some applications of logic, digital circuits, and we have also studied full adder and half adder circuits. Today we are going to start valid and invalid arguments. The lecture outline is as: first of all, I shall define what is an argument and different forms of the arguments. Then we shall study modus ponens, modus tollens, and some other additional valid forms of the arguments. We shall also see by examples valid arguments with false conclusion and invalid argument with true conclusion. In the subsequent sections we will study converse and inverse error in the arguments. At last we shall study contradictions and valid arguments. So what is an argument? An argument is a sequence of statements. All statements but the final one are called all statements but the final one are called premises or assumptions or hypotheses. The final statement is called the conclusion. Normally we place this symbol before the conclusion and read as therefore. This is normally placed before the conclusion. For example, what is an argument? If Socrates is a human being, then Socrates is mortal. Socrates आप लोगों को पता ही होगा, Socrates जो है एक mathematician philosopher था. So if Socrates is a human being, then Socrates is mortal. Mortal means death comes to Socrates. So this is the first premises of the example. If Socrates is a human being, then Socrates is mortal. The second premises is Socrates is a human being. So these are two premises and this is the conclusion. Socrates is mortal. So in argument usually we have sequence of statements. On the basis of the truth values of these statements or premises, we draw some conclusion. So if Socrates is a human being, then Socrates is mortal. This statement as a whole is true. As a whole is true means that you know the conditional statements. What are the cases when the conditional statements are true? This is the hypothesis of this conditional statement and this is the conclusion of the conditional statement. So if hypothesis is true and conclusion is false, this conditional statement is false. In all other cases this conditional statement is true. But in arguments we suppose as a whole this premises is true. Means there are three cases. Socrates is a human being is true. Socrates is mortal is also true. Then as a whole this conditional statement is true. If Socrates is a human being, if it is false, and Socrates is mortal if it is false, then in this case also this conditional statement is true. You know all the cases when the conditional statements are true. Now as a whole we will suppose that this statement is true and also this statement is true. In arguments we suppose that all premises are true, and on the basis of these premises we draw the conclusion here. If Socrates is a human being, then Socrates is mortal is true, and the second statement here, Socrates is a human being, this is also true. Now if this statement is true, then conclusion Socrates is immortal, it cannot be false, because if we suppose that Socrates is mortal, then the first premises will be false. So we draw a conclusion from these two statements, from the first two statements or premises, or we say them also the hypotheses or assumptions. So on the basis of these assumptions or hypotheses, we draw a conclusion, therefore Socrates is mortal. So in general, an argument is a set of statements which are called premises, and on the basis of these premises we draw a conclusion. So one more thing, once again, that all premises, the first premises, second premises, as a whole, these premises are considered to be true, no matter what the individual statements means. In this premises there are two statements, Socrates is a human being, Socrates is immortal. No matter what the truth value of these individual statements in the premises are. So by considering as a whole premises true and the second premise is also true, we draw a conclusion that Socrates is mortal. What is an valid argument? To say that an argument is a valid form or argument form is valid means that no matter what particular statements are substituted for the statement variables in its premises, if the resulting premises are all true, then the conclusion is also true. So I have told you earlier that a valid argument, in which a valid argument or an argument is a set of statements or premises on the basis of which we draw a conclusion. So if all the premises are true, the conclusion must be true, no matter what the individual statements are used in premises. Now how can we prove that an argument is a valid argument? We can show that an argument is a valid argument by using truth tables. First of all, we shall identify what are premises and what is a conclusion in an argument. Secondly, we construct the truth table for premises and conclusion, and then we find the critical rows. I shall tell you later what are the critical rows in proving or identifying the valid arguments. We shall find the critical rows in which all premises are true. If in each critical row the conclusion is also true, then we say that this argument is a valid argument. We can, as we have discussed earlier, that statements can be transformed into symbols. If we take a valid argument into symbolic logic or symbols, for example, we have argument this, in which we have two premises, P implies Q and Q implies R. These two statements are premises, and the last statement, this is conclusion, as this sign of three dots, which is read as therefore, is put before this statement. So now how to prove this argument to be a valid argument? We shall construct a truth table for the premises and conclusion. To construct a truth table of these premises and conclusion, we need three variables, three, you can say, propositional variables, P, Q, R. So as we know that if we have three propositional variables, there are 8 possibilities of truth values in the truth table. So we write here P, Q, R, and the truth values of P, truth values of P, Q and R are written here. So these are 8 possibilities of P, Q, R. Now P implies R. We construct the truth table for premises then. These are 2 premises we have constructed. P implies R. You know the conditional statement, the truth values, all possible truth values of the conditional statements. You know, if P and R, here we will use P and R. P and R. If P is true, R is true, then conditional statement is true. If P is true, R is false, then conditional statement is false. You know, if P is true, true, here we have true, and true, false, 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 true. If we have false and true in conditional statement, then again the conditional statement is true, as you know. False, false, true, false, true, true, and false, false, true. Similarly, we have constructed the truth table for Q implies R for this, and then truth table for the conclusion, compound proposition, which is a conclusion, P or Q implies R. So now we see the critical rows. What are the critical rows? The critical rows are those rows in which the premises and conclusion, or you can say the premises. The critical rows are those rows in which the premises have truth value as true. So in first line here, both premises has truth value as true, as we can see here, T, which means true. And in this row also, the truth values of premises, both premises, here we have 2 premises. If we have more than 2 premises, then the critical rows will contain all the premises. So next, here we have true, false, true. This is not the critical row. Here we have true, true. This is a critical row, as all the truth values of the premises are true. Another, this row is also a critical row, as all truth values are true. This row is also a critical row, as all truth values are true for all possible premises. Now, to check the validity of an argument, we shall see that whether corresponding to each critical row the conclusion is true. Here the conclusion is true. Here we have conclusion is true. Here the conclusion is true. Here also the conclusion is true, and in the last the conclusion is true. So if corresponding to all critical rows the truth value in the conclusion column, or in conclusion, the truth value is also true for corresponding to each critical row, then we say that this argument is a valid argument. So once again I repeat, what are the critical rows? Critical rows of an argument are those rows in which all possible values of all premises are true. For example, here we have 2 premises, one this and second this. This is a critical row. Why? Because the truth values in this row are true for both premises, this and this. So critical rows are those rows in which all possible values of the premises are true. So first we identify the critical rows to prove, or to identify the argument is a valid argument, and next we see whether corresponding to each critical row the truth value in the conclusion column is also true. Here we have true, here we have true, here we have true, as we can see that here we have true, 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 and also here we have true. So this argument, the given argument, this is a valid argument. Next, we take another example in which we shall see an invalid argument. What is an invalid argument? Obviously, an argument which is not valid is called invalid argument. And how we prove an argument to be invalid? If corresponding to all critical rows at least one conclusion is false, at least one, कम से कम एक, then we say that this argument is not valid or this argument is invalid. For example, consider an example. Again, here we have two premises again and conclusion. So we construct the truth table for the premises and conclusion. As we have three propositional variables p, q, r, we constructed not p as we need it here in the second and third statements, compound statements. Not q, not r, q or r, p implies q or r. The first premises, this is the first premises, these are premises, and this is conclusion. So we constructed truth table for both premises and a conclusion. Now we decide, or we identify the critical rows. We have two premises. We see this is the critical row as all the truth values are true. This is again a critical row, and this is, these all three rows are critical rows as all possible truth values are true in these three rows. So these three are also critical rows. So now we see corresponding to each critical row the conclusion is true. Here it is true, here it is false. Now if at least one truth value in the conclusion corresponding to the critical row is false, we say that this argument is invalid. No matter the next critical rows have all truth values as true, we need only one truth value as a false corresponding in the conclusion corresponding to the critical row, then we say that this argument is invalid argument. So how to prove an argument to be valid and invalid? First of all, construct a truth table for all possible premises and conclusion, and then identify critical rows, and then we check whether in the conclusion all possible truth values are true corresponding to each premises. Then we say that this argument is valid, and in other case the argument is not valid or invalid. So next we see some forms of valid arguments which are, you can say, universally valid. Wherever we see these forms, we immediately understand or conclude that this is a valid argument. So first argument is this, in which we have two premises, if p then q and p therefore q. This is conclusion. The first, we can write it as p implies q, and if it p. Now I told you that these are two premises, and we suppose the truth value are true of both premises. So this conditional statement is true, and this statement is also true. On the basis of second statement which is p, if we suppose p is true, how we conclude from these valid argument forms? I'm trying to explain you this. If p is true, then the truth value of this conditional statement p implies q is also true. if P is true, then Q must be true. Why? If P is true and Q is false, then this conditional statement becomes as a whole false. As you know, the conditional statement is false only if P is true and Q is false. Now if we suppose that this P is true, then Q must be true. So what we have concluded from these two premises, that Q must be true also. So this argument form, which is called modus ponens, is a valid argument. Wherever we see this argument form, we immediately conclude that Q is also true. For example, if the last digit of this number is 0, of this number, any number, for example 10, if the last digit of this number is 0, then this number is divisible by 10. Then this number is divisible by 10. This is a conditional statement, which is the first premises. Now the second premises is, or second hypothesis is, the last digit of this number is 0. Now if the last number of this number is 0 is true, then this number is divisible by 10 must be true. Otherwise the truth value of this conditional statement will not be true. So what we have concluded from these two premises, that this number is divisible by 10. So this is basically a form of modus ponens, which is a valid argument. We shall discuss some other examples of modus ponens in the next slides. Now, what is the modus tollens? The modus tollens is basically another valid argument form in which the two premises are these: if P then Q, and not Q, therefore not P. Means if we have P implies Q and not Q, Q is false. Not Q is true. Not Q is true means Q is false. Means Q is false. Now, to be true for this conditional statement as a whole, P cannot be true. P must be false. Because if not Q is true, Q is Q. Basically, this is negation of Q. If negation of Q is true, then Q must be false. And as a whole of this conditional statement, this will be true only if P is false. So if P is false, not P will be true. So what we concluded from these two premises, from this argument, that if P and Q, P implies Q and not Q is true, then not P must also be true. This is the conclusion which we draw from this argument. This argument form is also always valid. We can prove it using truth tables also. And this form is called modus tollens. For example, if Zeus is human, then Zeus is mortal. This is the first premises, and the second premises is Zeus is not mortal. If Zeus is not mortal is true, and as a whole this conditional statement is true, then we must conclude that Zeus is not human. And the argument forms of this type are called modus tollens. Now we shall study some other examples. We shall see another example of modus ponens and modus tollens. How we recognize modus ponens and modus tollens. For example, I have given two examples here. The first premises, first hypothesis or assumption is, if there are more pigeons than there are pigeonholes, then two pigeons roost in the same hole. It means अगर आपके पास pigeon holes कम हैं और pigeons ज़्यादा हैं, means then two pigeons, the दो कबूतर roost in the same hole, दो कबूतर जो है at least, then two pigeons roost in the same hole, दो कबूतर एक ही pigeon hole means कबूतर का जो पिंजरा है उसमें बैठेंगे. So if there are more pigeons, अगर कबूतर ज़्यादा हैं और कबूतरों के पिंजरे जो हैं वो कम हैं, तो दो कबूतर जो हैं वो एक ही पिंजरे में बैठेंगे. This is basically compulsory, this ये लाजमी है. There are more pigeons than there are pigeonholes. This is another premises. This is the second premises. So second premises is true. This is true, that we know that there are more pigeons than there are pigeonholes. पिंजरे कम हैं और pigeons जो हैं, कबूतर जो हैं वो ज़्यादा हैं. This is true. Then what we conclude here? First we see what is the first premises. If there are more pigeons, then there are pigeonholes. This is P. Then two pigeons roost in the same hole, and this Q is basically true. This argument form has exactly the form like this: P implies Q and P. So if we have two arguments like this, P implies Q and P, where P is true and this conditional statement is also true, this is basically the modus ponens, and we conclude here Q, that two pigeons roost in the same hole. दो pigeons जो हैं वो same पिंजरे में या same pigeon hole में बैठेंगे. So this is basically the modus ponens. The next example is for modus tollens. If this number is divisible by 6, if we say that this is P, then it is divisible by 2. If we say it Q, this number is not divisible by 2. Here we have Q, here we have P, and here we have negation of Q. We can see easily here that it is divisible by 2 and this number is not divisible by 2. These are the negation of each other. So what is this basically? If we have P implies Q and not Q, so this is basically the premises of modus tollens. We immediately conclude that not P. So this is the modus tollens and how we recognize these valid argument forms. So next is some other valid argument forms which we usually see in the next topics, or next how to prove an argument to be valid. Disjunctive addition. If P is true, if we know that P is true, P, this is any propositional variable. For example, we have given Socrates is a human being. We have seen the example earlier. That is a human being. Now this is true. We can add by ourselves. If P is true, we can write P or Q. If P is true, then P or Q must also be true, because there is a disjunction between P or Q. No matter what the truth value of Q, the conclusion as a whole will be true. If Q is false, we know P is true. If Q is true, P or Q both are true, then it is true. If P is true, Q may be false, then again P or Q will be true, because there is a disjunction between P and Q. We can say if Socrates is a human being, we can also say that Socrates is a human being and Socrates has 4 legs or 5 legs or 6 arms. Now the Q is false, even then P or Q is true. So such type of argument in which we have only one premises assumption and we can draw the conclusion, we can add the disjunction operator along with the propositional variable in P. So this is called, such type of arguments are called disjunctive addition. We can add any other variable by using disjunction operator into any true proposition. Similarly, if we have Q, we can again write P or Q. So this is the same argument, except we have supposed that here the premises is Q. Again we can write therefore P or Q. So this is a disjunctive addition. The next is conjunctive simplification. So if we have P and Q, this is basically, if we have P and Q, this premises is true, then what we can conclude from this premises or from this compound proposition, that both P and Q must be true for this premises to be true. So if P and Q is true as a whole, what we can conclude, P is also true, therefore we can say P is also true, or we can say that Q is also true. So we can simplify this premises P and Q into therefore P. So this basically, we simplify the conjunction operator here, therefore it is called conjunctive simplification. So once again I repeat it, in conjunctive simplification P and Q, if we suppose this premises, first premises is true, P and Q, then this is only true when P and Q both are true. So we can conclude, if P and Q is true, we can conclude P is true, or we can conclude Q is also true. Suppose we see an example for this. Suppose that it is snowing and cloudy. Is true. This basically the conjunctive compound proposition where there is a conjunction between these two propositions. Suppose it is snowing and it is cloudy. Cloudy is true. Using the conjunctive rule or conjunctive simplification, what conclusion can be drawn? If we suppose P is a proposition, it is snowing, Q is it is cloudy, therefore P and Q, we can conclude therefore P, if P and Q is true, then we can conclude it is snowing. We can simplify or we can leave this from the conjunction of P and Q. Similarly, we can write it is cloudy. This is also true because P and Q is true. This premises is true, P and Q, then we can conclude it is cloudy. We can also conclude it is snowing. So this type of argument is said to be conjunctive simplification. We simplify the compound proposition. Next is disjunctive syllogism. In disjunctive syllogism, we suppose we have two premises and the conclusion. Now, as we have discussed earlier, that in an argument we suppose that all premises are true, and on the basis of the truth value of the premises we draw a conclusion. Here we suppose that as a whole P or Q is true and not Q is also true. So what we can conclude from these two premises, if P or Q is true and we know that not Q is also true. Now here not Q is true, then Q must be false, and q must be false. Now for this premises to be true, what we must have p to be true. So we can write here therefore p. So this type of argument is called disjunctive syllogism. Similarly, we have another form in which we suppose not p is true, we can conclude q must be true. So we see an example for this disjunctive syllogism. Suppose I have a dime or a quarter in my pocket. I have a dime. What do we mean by dime here? Dime is basically the equivalent to 10 cents, 10 cents of a dollar. ये एक basically सिक्का होता है. A dime is equivalent to 10 cents, 10 पैसे आप कह सकते हैं. अगर 1 रुपए को फॉर एग्जांपल $1 के इक्वल हम ले लें तो 10 पैसे जो हैं एक डाइम हैं in the context of dollar. और एक क्वार्टर इन माई पॉकेट, क्वार्टर मीन्स अगर आप 10 सेंट्स एक डाइम को कहते हैं तो क्वार्टर क्या होगा, 2.5 सेंट्स हैं आपकी पॉकेट में. आई हैव अ डाइम और a quarter in my pocket. So there is a or between these two statements. So we can suppose this to be p and this to be q, and this is basically the first premises. Now the second premises is I do not have a dime in my pocket. मेरे पास 10 सेंट्स का सिक्का नहीं है मेरी जेब में. So what we can conclude here, we write it, first of all we write this argument form in the symbolic form here, d or q, where d, what is d? D, I have a dime in my pocket, and q, I have a quarter in my pocket. So d or q, and the second premises is not q, not d, sorry. So what we can conclude by using disjunctive syllogism, we can conclude therefore q, d or q is true as a whole, not d is true. If not d is true, q is false. Then d or q to be true, we must have d, we must have q as a true. Here not d is true, so d is false, then q must be true to get the truth value as a true of this first premises. So we can conclude that q is also true here. So we conclude that q and or I have a quarter in my pocket, मेरी जेब में 2.5 सेंट्स हैं, 2.5 सेंट्स का एक सिक्का है. We can say this. Now what is the next? Next is the hypothetical syllogism. Hypothetical syllogism is basically this argument in which we have first premises, second premises, and then conclusion. If we have p implies q and q implies r, then we must have p implies r. So this is basically the conclusion. So if we take an example for this, if this is divisible by 18, then divisible by 9, and if 18,486 is divisible by 9, then sum of the digits of this is divisible by 9. So these are two premises. This is the first premises and this is the second premises. What we can conclude by using hypothetical syllogism, if 18,486 is divisible by 18, then what? Then the sum of digits of 18486 is divisible by 9. You can check basically if we sum up 1, 8, 9, 4, 13, 21 and 27. So if we sum up these digits, we get 27, and 27 is divisible by 9. So if this premises, the first premises is true, the second premise is true, we can conclude here that if 18,486 is divisible by 18, then the sum of digits of this number is also divisible by 9. So we can conclude this by using this argument. This argument is called hypothetical syllogism. So the next form is basically the dilemma. We shall discuss this form in detail when we shall study the proofs. What is the argument form? In this argument form we have three premises, P or Q. P implies Q, Q implies R, therefore R. So in some situations we get the arguments of this type. For example, in mathematics, if we say x is positive or x is negative, if we say this as a P, x is negative, and Q, x is negative, so we get P or Q. And if P, then R. What is R? R is basically the proposition which is x greater than 0, and if x is negative, if Q, then R. So therefore we can conclude x square is greater than 0. So such type of argument is called dilemma. Next, we consider an application in daily life, how we use the logic and valid or invalid argument forms to find the glasses. Usually some people forget their things. For example, sometimes I forget my glasses or my mobile. I put it somewhere in the kitchen or in my room and I forget where I have kept that thing. And I remember some clues where I forget my glasses or mobile, and I construct an argument on the basis of my memories, which I try to remember where I have put my glasses in the room or in my office. So similarly, a person forget his glasses at somewhere in his home, and he reminds some sentences or some statements in his mind to find or to search his glasses. For example, let us consider the following statements which are true, which that man suppose that these statements are true. He supposed that if my glasses are on the kitchen table, my glasses are on kitchen table, I saw them at the breakfast. So normally a person does his breakfast in the kitchen. So he supposed the first statement, if my glasses are on the kitchen table, then I saw them at the breakfast. So this is basically the first premises, which I called as A. This is our second premises, what he thought. I was reading newspaper in the living room, or basically we identify the connectives also. I was reading the newspaper in the kitchen. So now that person tries to remind where he put the glasses. The third premises, he suppose I call it C. if I was reading the newspaper in the living room, then my glasses are on the coffee table. Usually the person or people read newspapers, and along with it they take a cup of coffee. So he supposed that if I was reading the newspaper in the living room, then my glasses are on the coffee table. Another assumption, hypothesis, he made that I did not see my glasses at breakfast. Then he reminds that मैंने नाश्ता करते हुए अपनी glasses को नहीं देखा. So next, an assumption he made, if I was reading my book in the bed, then my glasses are on the bed table. This is also a valid premises, because sometimes people read books in their bed and at night, and before sleeping they remove their glasses and put on the side table near the bed. So the last assumption he made, if I was reading the newspaper in the kitchen, then my glasses are on the kitchen table. So the last assumption, these are the set of 6 assumptions that may made just to remind where he put or where he forget his glasses. Now this is basically an argument, and we shall apply the logic to find his glasses. So first of all, we suppose that all these assumptions are true. These premises are true as a whole. We say that this is as a whole, this premises, this assumption is true, this assumption is also true, this assumption is also true that he made, this assumption is also true, this assumption is also true, this assumption is also true. So these are our premises, and now using the logic we have to draw a conclusion where he forget or where he put his glosses. So first of all, we shall transform this argument from English to the logical language or symbol. If we suppose that if my glasses are on the kitchen table P, we suppose the propositional variables to transform this English form or statements form into logical form. I saw them at the breakfast, we suppose it Q. I was reading the newspaper in the living room, we say it R. I was reading the newspaper in the kitchen S. I was reading the newspaper in the living room. This is basically again this is R, because I was reading the newspaper in the living room. We have supposed this statement as a R. So this is basically again the R. Then my glasses are on the coffee table. This we suppose it T. Here I hope you understand. I supposed here I was reading the newspaper in the living room, as we name it, this proposition is R. So if a proposition is repeated in the argument, we keep the same notation of the propositional variable. Here we have I was reading newspaper in the living room. Here again this sentence or the statement, this proposition came. If I was reading the newspaper in the living room, we give it the same name. We cannot change the notation of the same propositional variables. This will create confusion in the argument form, and we will not be able to draw some valid conclusion. So then my glasses are on the coffee table, we suppose a T. I didn't see my glasses at breakfast. So whether we have already supposed this proposition, so this here we have supposed that I saw them means glasses at the breakfast. So we have already supposed that I saw the glasses at the breakfast as Q. Now here this is the negation of this proposition, basically Q. So this is basically not Q. So we have supposed already a Q as a propositional proposition, and here if we have negation we just write not Q. I repeat here that do not give two different proposition variables to the two same propositions. हम दो एक जैसे propositions को दो मुख्तलिफ नाम अगर देंगे तो we will not be able to draw some valid conclusion on the basis of premises. So this is the very important thing which you have to remember or you have to care about. So the next E is, if I was reading my book in the bed, so this is basically a new proposition, we call it TU. Then my glasses are on the bed table, this is also a new proposition, we say it V. If I was reading the newspaper in the kitchen, so we have already supposed it, I was reading the newspaper in the kitchen, here it is. If my glasses are on the kitchen table or kitchen, kitchen, we have supposed it, I was reading the newspaper in the kitchen, I was reading the newspaper in the kitchen, we have supposed it as S here. I was reading the newspaper in the kitchen, so this is basically again the S. So then my glasses are on the kitchen table, then my glasses are on the kitchen table, we have supposed it as a P here. If my glasses are on the kitchen table, so here we have S and here we have P. So now once we have given the names to the propositions, then we see what are the logical forms used in these premises or propositional statements. Here we have if, here we have then. This is basically the form if P comma Q. We can write a conditional statement like this, P implies Q. So this, the first premises is basically the conditional statement. The second premises is what I was reading the newspaper in the living room or I was reading the newspaper in the kitchen. So here we can write R or S. There is a disjunctive operator between R and S. So in third premises what we have if. So this is basically also the conditional statement. If I was reading the newspaper in the living room, then my glasses are on the coffee table. We suppose R and T, so this is basically R implies T. So I didn't see my glasses at breakfast. We have supposed it not Q, so this is basically the not Q. The next premises or assumption is E. In this E we have if and then. So this is basically the conditional statement of U and V. We can write it as U implies V. The last premises is if I was reading the newspaper in the kitchen, then my glasses are on the kitchen table. This is also a conditional statement of S and P, so we can write S implies P. So I summarize here. This is basically here we have these, the symbolic form of this argument. Here we have supposed let P, my glasses are on the kitchen table, Q as we have discussed earlier, what is P and what is Q. And so now the previous argument now is in symbolic or logical forms, where A, B, C, D, E, F are premises. Now what the question is? The question is, where are the glasses? where that man forget his glasses. So first we have transformed the argument into logical form using logical connectives, implications, disjunction, negation. We have transformed our argument in the logical form or symbolic notation. Now using these premises and using the different valid argument forms which we have studied earlier, modus ponens, modal tollens, conjunctive simplification, disjunctive addition, and etc. We will use these valid argument forms to draw some conclusion from the given premises. Now, how we connect these premises? We can connect, or we can combine any 2 or 3 or 4 premises to draw a conclusion. For example, here I have written the symbolic notation of the premises here again, just to remind. Now if we combine A in the first premises and D, the fifth premises, we can say that P implies Q, not Q. So what is this? This is basically the modus tollens. So from here we can draw not P, therefore not P. This we have used, this we can conclude by using modus tollens. Now we can connect not P with the S implication P, or we connect this F, we connect this F and the conclusion of the first step, you can say. So we combine S implies P and not P, and what is this? This is basically again the modus tollens. We can therefore conclude not S. Now with not S we can combine this fourth premises R or S. Now R or S can be combined with not S, which is basically the conclusion of second step, you can say. Now R or S and not S, what is this? This is basically the disjunctive syllogism. So we can conclude therefore R is true. Now R can be connected with this premises R implies T. So in the fourth step we combine R implies T and the conclusion of previous step, third step. So what is this? R implies T and R. R implies T is true, R is true. What we conclude by using modus ponens, therefore T. Now we examine here whether we can connect T with the remaining propositions, with the remaining premises. We are left only with one premises here, which is this E. Now in E we have two different U and V, and we have premises U implies V. Now in any other premises U and V are not used. So this is basically the redundant premises, you can say. ये एक फालतू premises है. Sometimes arguments में या valid arguments में कुछ ऐसी premises भी होती हैं जो कि हमें conclusions draw करने में मदद नहीं देती. So we just leave such type of premises which have no connection with other premises. So as we use some valid argument forms to draw the conclusion, so we can say that most of the premises and the propositional variables may be connected in somewhat there must be somewhat connection between the propositional variables in the premises to draw a valid conclusion. Or, as I have told you, that do not repeat the names of propositions, in the argument. So we can connect two premises or two or more premises to draw a conclusion using some valid argument forms. So such type of premises which have no connection with other premises, these premises are redundant, or you can say faltu premises hai. So we can just leave such type of premises. So here we have drawn a conclusion, therefore T. So T cannot be connected with other premises, so we accept it as a conclusion. What was T? T was, we have supposed here, T, my glasses are on the coffee table. So now, what is the conclusion of this argument, where to find the glasses a man reminds some sentences, or you can say statements in his mind, and he developed an argument, and on the basis of these assumptions he wants to draw a conclusion. So now he draws a conclusion that on the basis of his assumptions, that his glasses must be on the coffee table. So this is basically the answer, where he forgets his glasses. Now he can go to the coffee table and pick up his glasses. So उसकी glasses ऐसे याद आ सकती हैं, या वो इस तरह वो अपनी glasses को find कर सकता है. So you see how the logic has helped us to solve some daily life problems, or such type of problems we can solve using logic or arguments. The next, there are some common types of errors which we do in the logic of valid and invalid arguments. What are the errors? What are the major errors? First error is called the converse error. So what is the converse error? People usually think P implies Q. This is also the modus tollens. If we if we see carefully, that modus tollens is basically P implies Q and P. Therefore, we conclude Q. So this is basically the modus tollens. Now, sometimes people write P implies Q and the second statement as Q, and they conclude as P. So this is basically an invalid argument, or this argument form is not valid. So such type of error is called converse error. Why it is called converse error? Because if we take the converse of this conditional statement, what is the converse? The converse of this a conditional proposition is Q implies P. If we take its converse and the remaining premises will be same, then we can conclude as P. So now this is basically the true form of modus tollens, which is equivalent to this form. So why this type of error is called converse error? Because if we take the converse of conditional statement P implies Q, then this forms becomes a valid argument form, which is modus ponens. Then it becomes a valid argument form. Therefore, we call it converse error. So please avoid such type of error when you try to prove some argument form a valid, or you draw a conclusion from an argument. by using some valid argument forms, then please avoid such type of mistakes. For example, if John is a cheater, then John sits in the back row. So this is the first basically premises. This is the first premises, John is a cheater, then John sits in the back row. So cheating करने के लिए आपको पता है कि back rows में ही बैठना पड़ता है. This is the first premises. The second premises is John sits in the back row. Now this is basically true. This statement is true and this as a whole true. Now if we suppose this is true, and even if we take it false, it remains true. What is the conclusion? John is a cheater, not teacher. John is a cheater. So this is true. Now this is true, but here we call it false. So there is an error in this argument form. So which is a converse error. So don't replace P here by Q. Basically, sometimes people write here Q in place of P. Here in modus ponens we have P, remember it. So don't commit such type of errors in the argument forms. The next error is of type inverse error. So what is this and why it is an error? Basically, if we have P implies Q, and in the modus tollens we have not Q and the conclusion is not P. So instead of writing not Q here, if someone write here not P and draws the conclusion not Q, then he has replaced a conclusion by a premises and a premises by a conclusion. So such type of error is called inverse error. So why it is called inverse error? If we take the inverse of conditional statement P implies Q, then this argument form becomes valid argument form. So as I have told you earlier, if we take the inverse of P implies Q, then it becomes a valid argument form. Therefore it is called inverse error in the valid argument forms. For example, if interest rates are going up, stock market prices will go down, and interest rates are not going up, and we draw a conclusion, so stock market prices will not go down. So such type, the same error one commits here, which is called the inverse error. So please avoid such type of errors in the valid argument forms in improving an argument to be valid, or if you want to draw a valid conclusion or a true conclusion from an argument, then you must avoid such type of errors in the simplification. The next is valid argument with false conclusion. Sometimes you see some valid arguments, but in real life the conclusion is false. For example, if we take, if Jackson is a president of the United States, Michael Jackson is a president of United States, basically in real life this is wrong. Jackson was never president of United States. Then Jackson must be younger than 35, and this is basically the first premises, first and the second premises. Jackson is a president of the United States, therefore we can conclude Jackson must be younger than 35. Basically this argument form is valid. If we transform it into symbols, Jackson is a president P, Jackson is younger than 35 Q, then we have P here and therefore Q. Now this form in logic, in arguments, this form is basically a valid form, which is modus ponens, we have studied earlier. This argument form is valid. There is no mistake you can say by using logic this argument is valid and the conclusion is also valid. But the individual premises P is not true in real life, in real world. Jackson was never president of United States, and Jackson, now when he died, he was not younger than 35 years. So the individual statements have basically, you can say, false, or this argument form is not, you can say, is not, doesn't make any sense. So such type of valid arguments in which the conclusion in real life problems can be false. So if the conclusion in this valid argument form is Jackson must be younger than 35, Jackson कभी 35 से छोटा था, लेकिन 35 से बड़ा भी था वो जब वो उसकी डेथ हुई, तो he was 55, I think, or 51 years old. So this statement is basically ambiguous statement. So such type of argument is basically, it doesn't make sense. So in logical form, in symbolical form, this is basically a valid argument form, but in real life problems the conclusion which we have drawn is false, which is just because that the individual statements which are used here in this argument, they doesn't make sense, or they are false. So next we have another situation where the argument form is invalid and we draw the true conclusion in real life problems or in real world. For example, if we consider this argument which have two premises and this is conclusion. If New York is a big city, this is true, then New York has tall buildings. So this is also true. New York has tall buildings. Basically you are P, saying P implies Q, and you are drawing a conclusion, therefore P. So this is basically, New York is a big city, this is basically true. So the conclusion is true, but the form of this argument is not valid, because as we have studied the converse error, there is a error which is converse error in this argument form. We have studied earlier the converse error. So this argument form is not valid, but the conclusion which we have drawn on the basis of true premises, the conclusion is true. So we have situations where we have invalid argument forms, but we draw the true conclusion. So avoid such type of errors also in drawing conclusion from the set of premises or to prove an argument form to be valid. So for today it is enough, and we stop until here. So the lecture summary, what we have studied today: different forms of arguments we have studied, how to prove an argument to be valid. We have studied the method using truth tables. We can prove an argument to be valid, and then we have studied different forms of valid arguments, which are modus ponens, modus tollens, disjunctive, addition, conjunctive, simplification, and some other valid argument forms. And we have solved, or we have done an application of argument forms. We have found the glasses of that man which he forgot on the coffee table. We have studied also some invalid forms with true conclusion and valid forms with false conclusions. And lastly, we have studied the converse and inverse error. So In the next lecture, we shall study predicates and quantifiers. Until then, Allah Hafiz.